Well, good afternoon, everyone. I think we will go ahead and start the webinar as others continue to join. But I really wanted to welcome everybody here. We are so excited to be hosting this webinar today. The webinar is being hosted by the National Institute of Statistical Sciences, or NISS, and the Federal Committee on Statistical Methodology. And we are just delighted to have all of these speakers here today to talk about AI in federal government. And the goal of today is to really begin the discussion about challenges in confidentiality, privacy, and ethics for use of AI by federal agencies. My name is Lisa Mirel, and I am going to be the moderator for today's session. And I'm really excited to hear all of these talks and to have a really great discussion afterwards. Our talks today are being sponsored by ASA, RTI International, and NORC at the University of Chicago. And we really want to acknowledge our sponsors and thank them for really helping to make this event happen today. Okay, so today we have 4 speakers. I'm actually going to go, even though it's not exactly on the slide, but I'm going to do a brief intro for each of them in the order that they will be presenting. So today we have Kristi Boyd from SAS, and she is going to be presenting about ethical AI in government, recognizing bias across the data and AI lifecycle. And just a quick bio about Kristi. She is the trustworthy AI specialist at SAS, which is supporting the company's responsible innovation and trustworthy AI strategy. Her expertise as an AI ethicist is enhanced by her international business and technology ethics degree, her certification in CIPT, and her experience in QA and product management. She speaks regularly on AI ethics and governance and has contributed to publications through Duke Graduate School, IAPP, Equal AI, ACAMS, Today, Cosmos Compliance, and SAS.com. Our second speaker today is going to be Emily Hadley from RTI International. And she's going to talk about practical approaches for ensuring the responsible use of AI. Quick bio on Emily. She is a research data scientist with RTI International, which is an independent nonprofit research institute dedicated to improving the human condition. In her work, Emily collaborates with subject matter experts to solve complex problems in health, education, and justice using data science and statistical methods. Emily's main research interests are in exploring technical and policy approaches to addressing bias, equity, and ethics in data science. Our third speaker is Benjamin Reist from NORC at the University of Chicago. His talk is titled Addressing Algorithms, Bias, Fairness in AI Systems. And just some background on Benjamin. He is a principal statistician in the Statistics and Data Science Department for NORC at the University of Chicago. He has over 15 years of statistical consulting experience in the areas of sample design, model-assisted estimation, survival analysis, adaptive survey design, variance estimation, analysis of complex survey data, experimental design, missing data, paradata, quality metrics, data governance, and disclosure avoidance. And he has had several different positions across government, including NASA, NISS, the U.S. Census Bureau as well. He was the Deputy Chief Data Officer at NASA and the Deputy Director for Science and Planning at NISS. At the Census Bureau, he held numerous positions, including Survey Director and Lead Scientist for the National Survey of College Graduates, and Assistant Center Chief in the Center for Adaptive Design. And our last speaker today is Ellen Galantucci from the Federal Maritime Commission. Her talk is titled Safeguarding Confidentiality in Federal Statistics, Navigating AI Challenges. And a bit about Emily. She is a senior data scientist at the Federal Maritime Commission. Ellen's work at FMC focuses on modernizing data analysis, methods, data collection, and developing policies for publishing data. Prior to working at the FMC, Ellen worked as a research mathematical statistician at the Bureau of Labor Statistics, where she focused on disclosure limitation, machine learning, and data linkage. All right, just a couple of things before we get into the chat. We are planning to have a discussion at the end of the chat, so we'll open it up for questions at that point. But after the talks or even during the talks, feel free to use the Q&A feature in Zoom to put your questions in. And, if it can be addressed by the speaker once their talk is over, they will do that. Otherwise, we will raise it during the discussion to have a broader conversation. All right, thank you all again for joining today. And we're just really excited to have this session today. Thank you. All right, we'll turn it over to you, Kristi.
Thank you, Lisa. Appreciate the introduction, and thank you everybody for joining today. I know we have quite a variety of participants on the call, so excited to have the conversation and excited to hear what the rest of the panel has to say afterwards as well. I'm going to go share my screen. Lisa, I would appreciate if you let me know if you can see it.
I can
Hopefully,
see it. Looks good.
perfect. No technical issues so far. So what I wanted to talk about today is ethical AI governance. And you might have noticed during the introductions that I'm not a statistician. I'm not a data scientist necessarily, very different from the rest of the panelists. But I think it's the way that the panel was set up is very intentional. And I think having different voices highlighting this conversation, having different voices participating in the conversation about, well, how do we use AI is so important from a socio-technical perspective. And so what I want to do for the next 15 to 20 minutes or so is to do a double click on ethical AI. What does that mean? Why does the ethics matter? Why don't we just focus on privacy or confidentiality or anything else? And really set the stage for some of the more technical conversations that we're going to have with the rest of the panelists. So first off, maybe this is redundant for the audience, but I always like to start any sort of AI conversation with definitions because AI has become such a buzzword and there's so much different publications and voices and opinions about what AI is and how it's impacting all of us. But I very rarely see a baseline of, well, what are we actually talking about? Especially because a lot of this is my personal kryptonite nowadays, but I see way too many articles telling me that there's this new technology and it's so broad and it's so et cetera, et cetera. And so I wanted to start off by saying, well, what is AI? Really, when we're talking about AI, it's familiar. All of us use artificial intelligence daily, I venture to say, whether we recognize it or not. If you're using a navigator to get to work or pick up your kids from school or go to the grocery store, or whatever it is, those navigators are using various types of artificial intelligence, typically. If you are a runner and you use a Garmin or a Fitbit or an Apple Watch to track your health, to track your steps, you're using artificial intelligence. Even something as simple as checking your email, especially if you use Gmail or any of those products, your email uses artificial intelligence to filter out spam emails. And so I think it's important to start with baselining that AI is really familiar to all of us. I know a lot of time conversations get very technical or very specific, and some of the audience feels alienated, like we're not familiar with it, we don't know what it is. In reality, most of us use AI daily or at least weekly to do a lot of tasks without recognizing it ourselves. So, first off, AI is really familiar. There's a lot of ways we can use it, there's a lot of ways we are currently using it. And it's important, I think, to start with that statute of comfort, if you will, that we know what it is. And secondly, also, this is, like I said, one of my personal pet peeves nowadays, but AI has been around for a little while. AI, I know, really got into the front news, the top headlines in about 2022 and with ChatGPT. But as a discipline, artificial intelligence has been around for a long, long time. I can tell you at SAS, company I work for, we've had neural networks in production for 37 years, right? Neural networks is a type of artificial intelligence systems. And initially, the very first mention of AI really is in the late 50s. I believe it was a Stanford conference, if I'm not mistaken. And since the years, yes, the technology has developed and we've iterated, and some of the rebranding has occurred as well. We've gone through neural networks to machine learning, deep learning, and now we're talking about generative AI primarily. But again, this discipline has been around for a little while, which is a good thing for us. It means that there's a good amount of thinking and a good amount of people that have thought about how is AI being used, how is it impacting us, so that when we're talking about ethical use of AI or challenges of privacy in AI, we're not starting from a blank slate. We're starting with a pretty robust body of work and body of thinking, and also experience that we can really capitalize on while we're talking about artificial intelligence. So that's the baselining. I think I mentioned again that AI is really impacting all the different domains, whether it's from a financial sector to the criminal justice system. There's a number of questions that are impacting how we're answering those questions, how decisions are being made. And AI is impacting how we are deriving insights from our data. Obviously, this is directly applicable to the various industries that are represented here on the slide and more. But I think from a federal context or from a regulatory context overall, it's so important to recognize that this is a opportunity and a challenge for all of us, right? Because AI is being used to impact consumers through their financial and from their retail perspectives, because AI is being used and can be applied in the criminal justice system or in the healthcare life sciences domain, it's important to recognize the broad scope of it and also recognize the opportunities for overlap or continuity and symbiosis so that we can not think so siloed, if you will, but recognize there's opportunities for us to learn from each other about how can AI be used. Just because I spend a lot of my time in the financial sector, for example, doesn't mean there's not something I can learn about good practices and best practices from practitioners in healthcare and life sciences or HR or education. And so I think it's important to recognize this broad impact that AI has on the different industries and the opportunities that it provides us in terms of learning best practices and answering some of the challenging questions about ethics again. The way I like to think about artificial intelligence is really through the three A's or AAA, if you will. And first, what AI really helps us do, and this is, I think, the bottom line of it all, is it helps us accelerate how we make decisions. Because of the computing capabilities that we have now, and because of the big data capabilities that we have, we can make decisions so much faster than we were previously able to. So we're accelerating that decision-making process. I worked in HR technology for quite a while, and I think this is an example applicable to regardless of your industry and agency, but when you're hiring people, when you're bringing in new employees, it used to take 2 to 3 minutes or so for a recruiter to scan a resume and make a decision on whether or not this is a good candidate, it's a yes or a no and a maybe. 2 to 3 minutes doesn't sound like a lot of time, but if you're scanning through hundreds of resumes and if you're managing multiple different requisitions, multiple open positions, that time adds up. And what AI has enabled us to do is to accelerate those capabilities, accelerate how quickly we can scan through a resume and make a decision on yes, no, and maybe. And that's a beneficial thing in terms of efficiency, productivity. Again, we're using our resources very effectively in this case. And it's accelerating how we're making decisions. We're now almost able to use, and we are able to use real-time data in real time to make real-world decisions. So that's the acceleration part on the left. What also happens is that we're also amplifying the impact of our decisions. So again, if it used to take 2 to 3 minutes for a recruiter to scan through a resume, that meant that within 2 to 3 minutes, a recruiter was impacting one person's life. They were making a decision on one person's resume of whether they're going to advance, not advance, or maybe put on hold for now. As AI is able to do it much faster, AI is able to scan thousands of resumes in 2 to 3 minutes. Now we're also amplifying how many people are getting impacted, how many people's life choices, if you will, or life opportunities are getting impacted. Yes, no, or maybe. Yes, you might get this opportunity. No, you're definitely not going to get this job. And maybe we'll see, but you're on hold. So we're really amplifying the impact and the scope of our decisions. And that could be a good thing or a bad thing. We can be amplifying something very positive. We can be amplifying how effectively and efficiently and appropriately somebody receives support from social systems and social networks. Or we could be amplifying something negative, such as, are we accidentally amplifying a discriminatory hiring system or a system that has a bias towards students from a specific college or employees from a specific background. So really thinking about that amplification intentionally, not only we're accelerating decision making, but making sure that we're not accelerating the wrong things and amplifying the wrong things. We're amplifying the decisions and the values we want to be amplifying. And it ties down to who's going to be accountable. When we're amplifying something, when a decision is being made, we have to be intentional in recognizing that there's consequences to that decision, whether a good or a bad decision. And somebody's going to be held responsible and accountable for how that decision was made and for the impact that decision had on individuals. So thinking through AI, not just as a fancy tool, but also as what are we amplifying? What are we accelerating? Who's being held accountable? I think is a really good framework to make sure that we're being intentional in our use, to make sure that we're accelerating the things we want to accelerate and accelerating the things that honestly are useful to accelerate. Not everything needs AI, making sure that we're amplifying the right things as well. There's a lot of different challenges that we could be amplifying unintentionally, and I could talk for hours and hours and hours. I'm not going to do that on any and all of these topics on the screen, but we have to remember that, again, amplification can be really beneficial and really positive, or it could run into some of the challenges of implementing and amplifying AI. Whether it's the privacy and security, discriminatory copyright infringement, etc., a lot of different ways that we can be thinking about it. And of course, within this context, within this conversation, I believe the rest of the panelists are going to talk through some of the privacy limitations, some of the confidentiality challenges, and how can we be using AI to frame and to address those challenges appropriately. But it's important to think through the variety of the different challenges and how they interplay. And part of why I like the graphic on the left here with the little gears is that it showcases to us and just reminds us that the challenges of AI, the ethics and confidentiality and privacy, even for this session, they're not separate. You can't be addressing the ethics but not touching the privacy. You can't make decisions about confidentiality without making a statement about certain ethics. And so really thinking about how those things are interwoven together and how they impact together helps us create a very comprehensive and intentional approach to our AI strategy. Like I mentioned, there's a lot of ways that AI can be used, and this is becoming recognized across the board. From a business perspective, we're thinking about, can AI help us make sense of our data? Is the way we're using AI curating and cultivating trust? Or is this actually creating distrust in our stakeholders? From a policymaker perspective, you're thinking about what is the transparency and what is the social impact of this specific technology on the different populations? Is this AI fair? Is this decision fair? Is it transparent? Do we understand how decision was made? Can we audit for it? If there's ever questions about safety and security, can we understand how the outcome came to be? And from a consumer perspective, of course, too, we're dealing with from a privacy aspect. Do I understand how my AI system is being used or how AI is being used on me? And I talk a lot about and think a lot about AI literacy. Do people understand? Do consumers understand when AI is being used on them? Are they aware of how AI shows up? I started this presentation just highlighting how AI is so typical in our day-to-day life. And something I find a lot talking to various different folks is that sometimes people don't understand that their spam filter is AI or that their ring system or their video doorbell is AI driven as well. So recognizing that consumer perspective, what is the awareness? What is the AI literacy? And what is the understanding of what capacity and agency do we have as individuals to opt into certain AI uses or opt out of certain AI uses and certain data uses as well? So really thinking about that broad spectrum of applications. Of course, would not be an AI panel if we didn't recognize and didn't even talk about the executive order recently. But I think the executive order really highlights the fact that this challenge of AI is being recognized, an opportunity of AI is being recognized at all the different levels. So from a safety and security and trustworthiness perspective, thinking through what are the considerations, what are the different aspects in our society, in our US context, I will say, in our US context that we need to be addressing and thinking through. So as we're looking at, again, consumer protection, privacy, what are we accelerating? What are we amplifying? Who's being held accountable? As we're thinking about worker support and workers' rights and literacy, what are we accelerating? What are we amplifying? And who's being held accountable? Thinking through those three concepts across the board. Like I said, I think the executive order really highlights that. And I'm not a lawyer, so I'm not going to go into details of the EEO. I'm sure there's much smarter people on this call that can talk through those details. But it highlights to us, I think, how we are coming to understanding and reckoning in the US of the importance of having safe, secure, and trustworthy development of artificial intelligence systems. Now, there's a word on the slide, there's a word in the EEO in the title, trustworthy, that I want to do a little bit of a double click on, because I think safe and secure, we understand those are words that we use pretty commonly in our language, but trustworthy is not as common depending on your context. So when we talk about trustworthy, what is it? From my perspective, I think trustworthy AI really boils down to a very simple question of asking not only can we do something, but should we do something? Yes, we can use an AI system to make this decision or to accelerate this decision, but should we? What is the value that we're going to be promoting? What is the ethics that we're going to be promoting if we're using this system? And then how are we building our AI system to promote and reflect the values that we want to be promoting and reflecting? Again, conversation today is going to be a lot about privacy and considerations of privacy. That is a value that intentionally is being built in and intentionally can be built in to the AI systems that are being designed, promoting the value for privacy, promoting a development and usage of AI that aligns with our values as a society, as an organization, and as an agency. And I think trustworthy AI also, in a way, is making sure that we're remembering the people that are impacted by each decision. The AI conversation tends to get very technical very quickly, and for a good reason. It's obviously technology, there's obviously a need to understand the intricacies of how the model is built, etc. But I think it's important to remember that behind each decision that's derived by an AI solution is typically an individual or a family or a society or a group, and recognizing the impact that the adjustments and the shifts that we're making can have and will likely have on those different individuals. That's really what trustworthy AI boils down to, is thinking not only can we do something, but should we do something? What are the values and who are the people? And thinking through from that perspective. There's different principles, of course. We're talking about privacy today and confidentiality. There's other ones that I've seen used broadly and a lot. And these are the principles that we can be embedding into our systems. We can be intentionally designing for human centricity, inclusivity, privacy, security. The principles on the screen are the 6 principles that we at SAS use. So when we design AI systems that we then provide to our customers, we think through, how do you design an AI system that is going to promote human well-being, that's going to ensure accessibility and inclusivity, that's going to identify proactively the accountability, the risks, and mitigate those risks as well. Be transparent about the explanations and being transparent about how this decision was made. Again, what are we accelerating? What are we amplifying? Who's responsible? And also recognizing the need for robust and safe systems, as well as respecting the privacy. So again, a lot of different principles that I've seen. These are some of the ones that we can be considering, but all of it ties into the ethical approach to AI. Thinking about what are the principles and what are the values that we're promoting and building into the systems that we're building, and how are those systems being used and applied. There's different ways we can think through it too. We can think of it through ethics driven by values and principles, which is what I just talked about. We can also think about it as context specific, or looking at the AI and analytics lifecycle, or the data lifecycle, or AI lifecycle. There's a lot of different names for it. But I wanted to give a couple of quick examples. So if we're looking at, say, public safety, how do we think through trustworthy AI? Well, we can think through breaking this down, breaking a use case. Say this is a model for crime statistics and strategy development for a specific area. We can create a model where we break it down and we think about the different stages of how AI is created. Again, I think it's helpful to think of AI not as a single tool, but as a process, as stages that we can interact with and affect. And you can think through, what is the data that we're collecting as we're managing the data? Are we introducing any availability bias? Are we respecting the privacy as we should be respecting? As we're creating the model and developing the model, what are we monitoring? Are we being intentional about the proxies? Say we have a very safe and secure model that doesn't use any PHI or PII or any identifying information, but we have some proxies introduced in there, some variables that can act as sensitive or as identifiable information. Thinking through that and thinking through within developing the model stage, what can we be doing? What are some of the practical steps? And I think one of the panelists is going to talk about that later today. And we can also think about, as we deploy the model, is there any automation bias? We can do something similar in the social services context. We can think through, as we're building a case, for example, for child protective cases, something we worked in. We can think through, what are the different biases? Again, what are the values that we're doing here? What are we introducing? Are we introducing a recall bias where we're trying to do our best to remember, but we may not remember the details? Are we thinking through potential biases, such as historic biases, that can be embedded into the model? And thinking through, as we're deploying our models, is there any shifts and drifts that we need to be aware of as well? These are various ways that we can implement our values and implement our ethics into how we're designing a model from a trustworthy perspective. We can do something similar for infrastructure. I'm not going to go through this in interest of time. We can think through that entire data analytics lifecycle and how, in the different stages, can we be stress testing for the values that we want to be promoting. Couple of different ways we can do it, but really thinking of it as a full socio-technical, thinking of it from a strategy perspective. Again, our oversight. What are the values that we're promoting? Are we overseeing them? Are we being intentional about how we're governing our models? Setting up the controls and the proper guardrails in place for any sensitive information, for any privacy impacting information, making sure that's reflected in our platform and in our technology. and also making sure that we have the right culture for this conversation. I think it's important that everybody in the organization is comfortable talking about ethics, bringing up privacy, bringing up confidentiality, and not just focusing on the one technology or focusing on the model, but making sure we're thinking about the people behind. There's tools and technology available all over that you can look at. We can share the slides afterwards, but again, interest of time, I'm not going to go through it. But we can think of technological solutions for some of the problems that we discussed as well. And I'd love to, I know there's a couple of Q&As that I saw pop up, so I'd love to address those as well. But for now, Lisa, I think I'll pass it over to you and to the rest of the panelists.
Excellent. Thank you so much, Kristi. Okay, we'll turn it over to Emily. Thank you.
Great, thanks so much. Let me just pull up the slides. Can you see the slides, Lisa?
That's
Awesome.
great.
Great, thanks so much. Hello, everybody. My name is Emily Hadley. I am a research data scientist with the RTI Center for Data Science and AI, and I'm thrilled to follow up on Kristi's fantastic introduction to responsible AI and its many components with a talk on practical approaches for ensuring the responsible use of AI. Kristi kind of mentioned that AI systems can cause harm, and I wanted to lead this portion of the presentation with some really specific examples from the AI incident database. This is one of the most widely known incident databases. It collects news articles on a variety of AI incidents, many of which have caused harm. And the three I've shown on the screen here are ones that I consider government or government adjacent. So there was recently an app deployed on the southern border for asylum applications where it looked like individuals with darker skin tones were having a harder time completing the application and completing a facial recognition component of the application, which is a well-known problem in the facial recognition space. We also saw a self-driving public bus in Las Vegas that was involved in a crash very quickly after it launched, and then an AI algorithm used by United Health, which was resulting in denials of care for Medicare Advantage plans. And kind of the key takeaway I want to start with in this presentation is that AI systems are already integrated into systems that Kristi mentioned in your personal life, but also into government systems, and in some cases have unfortunately caused harm. We are seeing moves towards more regulation. This is kind of a timeline over the past few years. The EU has moved particularly fast and just recently adopted their AI Act. But in the US, a lot of the regulations that we've seen have been voluntary initiatives or acts. And the US executive order last year was certainly a really exciting update in this space with many implications for government agencies. But there's a lot more that can be done. And so that's one of the pieces that I've been really thinking about in my work and my research is how can organizations act to ensure the responsible use of AI without needing to wait for federal government regulations. I'll note that most of this work is focused on a US context, but could likely be applicable in other areas as well. Kristi also did a wonderful introduction to AI. I just wanted to reiterate that when I'm talking about AI in this presentation, it's a really broad umbrella that refers to systems that have taken over tasks that normally require human intelligence, including making predictions, recommendations, and decisions. That includes everything from robots to image recognition to chatbots to forecasting. There's a lot of very different ways and long existing research fields that can be grouped together under the AI umbrella. And similarly, when I'm saying the words responsible AI, I'm saying AI that's developed in a value-driven process. And there's a lot of different concepts that have arisen in this definition of responsible AI. I've pulled out some here that come from the NISS risk management framework or from international definitions of responsible AI. A lot of really kind of key concepts and components that I won't spend too much time going into, but kind of just noting that responsible AI is also a very big umbrella that covers a lot of really core principles that are related to ethics as well. And the institutional actors involved in responsible AI, that includes the legislature, that includes individual states, universities, and other organizations, government agencies, and professional societies. I've seen all of these kind of groups work in ways that influence the culture of responsible AI, especially in the United States. And a lot of my work has focused on these institutions rather than individual developers. I am a data scientist. I use AI in my work. I collaborate with other groups that use AI. And I've certainly heard and recognized that we as individual developers and data scientists bring our own biases to this work that can really impact the final outcome. But the reason why I think it makes more sense to focus on institutions and cultivate a culture of responsible AI within institutions is that individual developers face a lot of different priorities. You know, we've got priorities related to funding, we've got priorities related to our time, to the hierarchical structure of management. And so it can be really challenging for any one person to kind of say, oh, this is biased or this could be biased, and then influence the degree of change that we really want to see within these within the space of AI. And so institutions, broadly speaking, are much better positioned to put in place policies and procedures and protocols and to really kind of address the very large space that is managing responsible AI. I'm going to reference some work that I published in late 2022. I'll note that this was before or right around the time that generative AI came out, and so it's not included in this paper. But if you want to know more about what I'm just about to talk about, I definitely recommend checking out this work that was presented in IEEE conference. And in this work, I really kind of honed in on 9 responsible AI policy approaches that I've heard in varying settings. So the first one is licensure or certification. That's the idea that we should have some sort of licensing or certification process for either individual developers or AI tools that are being developed. Post-deployment accountability. That's this idea that the courts and the legal system should be responsible for creating a culture of responsible AI. So, you know, if a self-driving car hits you, you could take that case to court and the court would decide who was responsible. Was it the company that created the car? Was it the software company? There's a lot of questions that the court systems may be really well positioned to answer when it comes to the responsible AI space. Policies that support education around responsible AI. Kristi mentioned that there's not a lot of consumer awareness of where AI systems are occurring, and especially of where they might be making mistakes and how someone might go about to appeal that mistake. And so I think that there's a lot of open areas here in the responsible AI education space. AI ethics statements. These are really common in the responsible AI space. We see these from countries and governments. We see these from government agencies. We see this from individual companies, and they're usually posted on their websites as a kind of a list of principles that they adhere to related to their use of AI. AI incident databases. This is something that I kind of launched this presentation with. They're used to track either AI inventories, which are a little bit different. They're a list of AI systems, but the incidents really capture moments when things went wrong with AI. Responsible research, support for responsible AI research. Most of this has been from the tech companies in the US, which presents a pretty significant conflict of interest where the companies that are developing the AI systems are also the ones who are doing the research on how to make sure their AI systems don't hurt people. Pre-deployment audits and assessments. This is what I'm really going to focus on in this presentation because I think this area is incredibly important and where the most impact can be had. And that's the idea that if you take a step back when you're doing the development and the work internally, you can stop a lot of these harms from happening before the tool is released. Community stakeholder involvement, which involves having people who are going to be impacted from the tool involved in the development. And then diversity in developers. So that would be the data scientists, the computer scientists, the various people involved in development, bringing more perspectives to the work. So I list all of those, and in the paper, I go into much greater depth on kind of the details of what those are. A key piece, though, is kind of this ranking idea of what different groups should be focused on. And one of those, probably most relevant to today's presentation, is this idea of what should US government agencies be focused on. And in this next slide, I kind of take the table and make it a little bit more clear of what I think the US government agencies should be focused on. And I really think that the highest priority for federal government agencies should be around pre-deployment audits and assessments, responsible AI research support, and something that I didn't include when I wrote this paper, but have been involved in at RTI over the past few years, are AI use policies and protocols. The reason that I think that the federal government agencies should be really focused on a lot of these topics is because they can create a lot of the policies and procedures internally, often in alignment with that executive order that's already been mentioned. Some of these other areas are ones that I think other organizations might be better positioned to support. And so I'm going to talk about the pre-deployment audit and assessment and the policies and protocols for the next few minutes. Responsible AI research support, again, really, really important. I think the government is really well positioned as a more third party, less conflict of interest institution that could support more responsible AI research. The three ideas I'm going to talk about, the first one is AI use policies and protocols. Like I mentioned, this was something that I didn't initially include in the first paper I wrote, but I think is really, really important and something we've really focused on at RTI over the last year. We've developed a multi-pronged approach to AI risk management with a focus on ensuring justice and equity. And we've got a couple of key components to help make that happen. The first is Gen AI policies and protocols. So we have very robust legal documentation within RTI for internal use that governs everything from productivity use, like when can you use Gen AI to help write your emails, to project use, to high-risk use case scenarios, like when do we allow chatbots and in what circumstances are chatbots permissible. We have a data governance committee, which helps review all of the AI use cases, especially ones that might use sensitive data or might present risk or harm to either the organization or to people. We've got an authorship policy about when Gen AI can be used to write text and when it can't. And then we've got a Gen AI sandbox where we can use generative AI systems safely within our firewalls. And all of these, I think, we've aimed to closely align them with the NISS AI risk management framework, which is kind of the leading documentation in this space for how to manage AI. The second AI idea I want to bring up is this concept of algorithm review boards. Algorithm review boards are inspired by IRBs, or institutional review boards, which are used to govern human subjects research, but they are distinct. And this idea is that you bring together people with technical expertise, legal expertise, ethical expertise, and kind of independent persons who are likely to be impacted by the technology. And you bring these folks together to review AI systems in-house before they're released to the general public. There's a lot of potential scopes for these ARBs. They can provide in-house expertise. They can discuss the motivation for some AI work and the potential impact. They can manage and review findings from an AI audit or assessment. They can help with go or no-go decisions for high-risk AI applications. And they can do periodic reviews and assessments of deployed tools. I'm a big fan of ARBs. And I am the first to also note that they have been tried in practice and not necessarily succeeded. These are all examples of tech companies that have publicly dismissed or reallocated ARBs or ARB-like teams. And so there's definitely some challenges that we've already seen. And so a lot of my research has been focused on, how can we overcome these? So over the past year, I interviewed a number of folks in industry and government and academia and tech, to ask them, does your organization use an ARB? What worked? What hasn't worked? How might an organization that has both an IRB and ARB balance these two? How does it compare to having something like a chief data ethics officer instead of a committee? How does it compare to certification of developers and audits or assessments? And I'm moving a little bit fast, but if you're really interested in this work, it's published on Archive and is currently pending peer review, and would definitely be willing to chat more about this research. And the last piece that I want to mention here is AI audits and assessments. I mentioned these as a really important policy that I think is going to see a lot more attention. The EU AI Act especially explicitly calls for some of these, and they have a long-standing history of being used in the finance sector in particular. When I'm saying AI audit or assessment, these two things are slightly different from one another. An AI audit is generally completed by an external or third party. It's extremely formal and structured. Its objective is often ethical, legal, or technical compliance. And finance is an example of an industry that has really strong risk management practices. And so they have had a history of doing audits of modeling within their systems. I've spoken to individuals in finance who said that the extension to AI audits was really not that challenging. And so they've kind of already incorporated AI audits into a lot of their review systems. And so I think we're going to see a lot of this in industries that maybe haven't historically had such strong risk management practices. The one that I've seen it happen first is health. A lot of hospitals and insurance companies appear to be incorporating their own auditing structures or assessment structures to move quickly to make sure that their AI systems are not harming patients or releasing patient data. AI assessments are similar to AI audits. The biggest difference is usually they're completed internally, so not necessarily by an external or third party. They're not necessarily as formal. There may not be some sort of standard that they're matching up to or a widely recognized standard, and their focus is often on understanding and improving AI systems, often with a focus on social impact and ethical implications. So really thinking, if we could release this tool, what might go wrong? I've seen these most used in the tech sector. Some companies require AI assessments for all of their tools before they're released, and I think that that's a trend that's likely to continue. The last piece that I wanted to mention today is that there's a ton of ongoing efforts in this space for how to do this in practice. One of the best resources I've found so far is the Catalog of Tools and Metrics for Trustworthy AI, which comes out of OECD. And it's a really tremendous catalog of these tools that we're using in practice. At RTI, we are working on developing our own internal assessment program for our AI systems that maybe will be used on other systems as well. And we're drawing heavily from some of this previous work. But my big takeaway for this whole piece is that organizations can take intentional steps now to ensure the responsible and ethical use of AI. I strongly encourage folks on this call to be advocates and ask what your organization is doing. And if you want to chat about how we've been doing things at RTI and some ideas that I've got for further research, I'm more than happy to do so. And on this last screen is my email. So thank you so much. I'm going to stop sharing and hand it over.
Excellent. Thank you, Emily. That was terrific. All right, Ben, we will turn it over to you now. Thank you.
You see my screen?
Yep, looks great.
Okay. So I'm going to take a little bit more narrow approach today and talk just about addressing algorithm bias and fairness in AI systems. And once again, my name is Ben Reist. I'm a principal statistician at NORC, but I did spend about 15 years in the federal government, mostly in official statistics, but also at NASA. So algorithm bias and fairness problem is not anything new. And as previous presenters have talked about, actual AI or different rebrandings of AI go back quite far. There's an early example of AI bias that comes from the St. George Hospital Medical School. In the late 70s and early 80s, they tried to develop a system to alleviate from their selection panel some of the work to just figure out who to interview. They developed this system using prior year selections. And in 1979, the scoring from the algorithm and the scoring from the panel was highly correlated. The problem was this algorithm systematically was biased against women and racial minorities, even though both race and gender were not part of the actual system. It did exacerbate selection issues that were already in the testing data that they used to develop from prior selections. So by bias, I kind of define what I mean here. One definition that I like for AI algorithm bias or algorithm bias in general is a systematic unfair discrimination against an individual or group of individuals. And we have many examples of this. There's an example in predictive policing. One idea in predictive policing would be to where crimes are in your city is where you should allocate more police. And it's been shown that that's kind of a cycle that kind of feeds into itself. because one of the things that they have learned is where more police are, more crime is reported. So you continually are putting more and more police in an area where crime is being actually identified, but that doesn't mean that's where crime actually is in a city. Facial recognition, which was talked by a previous speaker. Many of the facial recognition software out there commercially, it has been shown has trouble with people with darker complexions and women, and that's well documented. And there was a pretty big splash ProPublica piece on recommendations for bail hearings and bias, mostly towards people of color in their recommendations for bail hearings. So there are kind of three different places that algorithm bias has kind of been identified that can come in. Pre-existing bias, this is usually bias that's found in society. This is really what comes in through training data and is independent of the actual AI algorithm. It's really a reinforcing of the algorithm does of the pre-existing biases that we find in society already. Then there's an issue with technical bias. You can see these a lot of times in like search algorithms and other places where you might not have the computing power to do exactly what you want. In search algorithms, a lot of times how search results are actually ranked on a screen with a fixed amount of screen space can cause issues of bias. There is a kind of historic example of this in searches for flights that using a alphabetical sort, put American Airlines at the top, or different things about domestic flights, about how not having to change carriers might put domestic instead of international flights higher on the screen, and that those limitations of the technology or of the computing power can cause technical bias. And then there's one of the harder things to actually deal with, which is emergent bias, which is you launch a system and then things change around that system, either needing to update using new training data because of changes that have happened in society, or even users ending up using your system for something that it wasn't originally intended for. That bail recidivism topic sometimes has been used in sentencing or in parole, even though it wasn't originally designed for that, and that can cause some bias issues. So usually we frame kind of definitions of fairness or unbiasedness in kind of two major areas, and there's a bunch of different competing definitions for this. There are two major subsets. One is group fairness, which is equal treatment across groups, and you can usually think of this as protective classes like race or age or gender, or an point of view of individual fairness, that equal treatment across similar or like individuals should be followed. So some examples of group fairness ideas. So equalized odds, members from a protected group should have the same true positive and false positive rates without those without protected characteristics. Equal opportunity, and this is used a lot in the hiring setting, but members of protected groups have the same true positive rates without protected characteristics. And equal treatment, ratios of false negatives and false positives should be the same between protected groups and non-protected groups. Some ideas in individual fairness is fairness through awareness. Two individuals with similar attributes should have similar predictions. And similar in this case is sometimes a lot where these different metrics and definitions can be tweaked, but similarly in some type of inverse distance metric. And counterfactual fairness, if you just change the counterfactual of the protected characteristic or a characteristic of the individual, will that change the difference in the prediction? So one project I'm involved in at NORC is we're conducting a systematic review of peer-reviewed papers on AI and ML tools for bail setting, sentencing, and parole support systems. And preliminary results from this have found that almost none of the papers mention bias or fairness, and few provide metrics for measuring fairness. And there's little documentation on methods used for mitigation, if mitigation was used at all. So the actual penetration of thinking about bias and fairness, at least in the peer-reviewed literature in these criminal justice areas, has not taken hold. So some steps in ensuring fairness in algorithms is, first of all, you need to measure fairness. And many measures exist to evaluate fairness, especially depending on what definition of fairness you take. The next is to use techniques to mitigate bias, and these kind of fall into 3 different areas: pre-processing, in-processing, and post-processing. There needs to be periodic monitoring after development of the deployment of the algorithm, and then transparency for users and the public. So some here are 2 basic for binary response, at least, measures of fairness: disparate impact, which is the ratio of positives for having the attribute like gender, like being female over being male, and statistical parity difference, which is the difference between these 2 probabilities. And so those are some group fairness metrics. An individual fairness metrics is consistency metric, where you use clustering algorithms to find neighborhoods of people or entities, and you look at, on average, how many differences are you seeing for an individual compared to its neighbors. So in mitigating bias, as I said, there are kind of 3 areas where you can mitigate bias. One is in pre-processing, and this is actually seems to have been one area that has had the most kind of work done in it, and this is really altering the training data. A lot of the problems that we see that come in from algorithm bias have to do with biases that are already existing in the training data. And there are a couple of different methods, but one that's quite popular is reweighting the data in the training data to kind of negate some of the bias. In process, alters the model and kind of internally while you're fitting the model. One example of this is using an adversarial model approach, which basically uses an algorithm to fit your model, and then a model that tries to actually detect the bias and then goes back and forth until the adversarial model can no longer detect differences using the protected characteristics. And the last and probably most controversial of the kind of mitigation methods is to alter the actual results after the fitting of the model. And this is adjusting predictions for some in the protected groups, and there are some different ways of going about doing this. So to move to transparency, I think transparency is one of the places that the federal government has a good roadmap on how to do this. Transparency in the official statistics areas is something that we do all the time about our data. One example is using source and accuracy statements that provide with data users with concise information about data quality. An example of this is the Survey of Income and Program Participation the U.S. Census Bureau conducts, provides a source and accuracy statement that provides things such as the sample design and methodology, the data collection methods, how missing data is dealt with, an estimation methodology, and some measures of data quality, such as coverage measures and response rates. So there has been something that has grown in the field called model cards, which is something I'm sort of advocating here with transparency and algorithms, that we should take this source and accuracy statement approach and provide concise documentation for algorithms. Things like sources of training data, methods used, the intent of the use of the algorithm, evaluation of quality, and measures of performance, and fairness measures would fall into that measurements of performance. So some challenges I see for the federal system. One of the biggest ones is not all of the AI algorithms being developed or developed in-house, and a lot of them are black boxes that are being bought and are proprietary. So getting that information for transparency, or getting the information about how bias is dealt with, or even quality metrics, can be very difficult to get for these products that are bought. The other thing is that applications for AI evolve over time, and we're reusing applications in different modes that they are not always developed for. One that I think is growing issue is that bias and fairness is not clear for generative AI. When you are looking at ChatGPT and it provides you a whole paragraph or paper on something, how to actually measure in a system that's not necessarily a predictive algorithm what is bias or is fair. One thing internally at NORC that somebody had looked at was doing quick literature reviews using generative AI, and it was very clear from an evaluation that there was definitely a slant towards one side of the literature that came out of the generative AI, but that's kind of takes professional kind of evaluation and not quick metrics like we talked about today. And the last thing, to provide transparency, documentation methods require a lot of resources, and it requires time and effort for each system to provide that level of transparency, even something short as a source and accuracy statement. That's the end of my discussion. Thank you, and I hope to talk more about this in the discussion.
Excellent. Thank you, Ben. That was great. All right, Ellen, we'll turn it to you now.
Sharing my screen. How's it look?
Looks good. You're a little quiet. I don't know.
Okay, I can try to speak up.
Yep, that's perfect.
Thank you. Thank you, everyone, for having me today. As Lisa said, I am Ellen Galantucci. I work at the Federal Maritime Commission, and my goal today is to talk a little bit about confidentiality concerns when we are working with AI models. Now, I want to first start by saying what this talk isn't going to be. And that's that we've had a lot of discussions about how AI puts our data at risk. There are a lot of disclosure methods that have been used for a long time, and while they've evolved over time, they haven't changed so significantly until about the last decade. And part of the reason for our disclosure methods to change over the last decade is that the computing power of just on my own personal laptop has expanded exponentially. We have AI models that can back out data from tabular data that's based on confidential data. So we can do it's pretty easy now to determine confidential data or to very accurately predict confidential data based on tabular outputs by federal statistical agencies and other types of agencies that are putting out data. And so probably the most famous of these cases is the Decennial Census, who did a significant evaluation of the security of their data, the protection of their data, and determined that it is not safe because of AI models, and they've implemented differential privacy to protect their data further. So that's not really what I want to talk about today. So that's well established. I'm happy to have that conversation at a different time, but that's not the purpose of this talk. What I want to discuss alternatively is when we as government employees or as federal contractors are using AI, when we're building AI, when we're working in these realms, what types of risks we face with our data, what confidentiality risks are created by using AI as federal employees or contractors. And so as I started preparing for this talk, I sort of went down this road of looking at a specific project. I was going to go down and tell you a long, detailed information about a specific project and some of the risks that we came across as we were building a machine learning model. And then I stepped back and thought it might be better to frame this talk as different types of AI usage that we might have as federal employees or contractors and the risks associated with each of these. So instead, I'm providing you more of a high-level discussion of different types of AI that we might be using with federal data, and then thinking about how we might mitigate those risks. So if you are using AI, if you are using any of these types of models, you'd need to think more about some of the ways, the implications. And again, I'm happy to have that conversation, but it would take a lot longer than a 15 to 20-minute presentation. So I want to start at the most basic level of different types of AI models that federal employees and contractors might be using, and that is publicly available generative AI models. This is your ChatGPTs, your Grammarly's. There's a million of these now that exist, and they can help you do things like write or code or analysis. You put information into the system and it pops out something else. So I ask it a question and it gives me a paragraph or two of information to answer my question, or I say, this is the code that I would like to use to write, and I don't know how to write it in Python, and it will give me some code that I can attempt to use to do that evaluation. Now, I love these for a lot of reasons because they can be really useful. There's other ways that you can do these types of things, of course. So I do a lot of coding as a data scientist, and sometimes it's really challenging to figure out exactly what I need to accomplish. So I go to Google and I look at Stack Overflow, and the questions that people are asking there are not necessarily exactly what I had in mind, or they're not trying to accomplish the exact same type of goal. And so they're not always the most useful responses. But ChatGPT, I can put in exactly what I want, and it gives me pretty good responses to my coding needs. And the same is true with writing or analysis in these types of systems. This poses risks when we are using these types of models with federal information or any type of confidential data or confidential information. And so I put just some text from the user agreements of ChatGPT and Grammarly here. I'm sure that most of these have something similar. ChatGPT says we may use content, and by content, it means your inputs or their outputs to provide, maintain, develop, and improve our services. Grammarly says you grant us a license to use your user content for limited purposes, including customizing our products, developing new products or features. And then I just really like this one that says to convince other people that you're using it and they should as well. But what that means is that when you're putting information into these services, they can keep that information and they can use it to do things like build future models. And that's a really big problem. If I'm putting in confidential data and asking it to provide me output, asking it to help me code to analyze that data, it can store the information that I've given to it. Or if I'm providing writing, I had a long discussion with someone about Grammarly where they said, well, all I'm doing is asking it to help me fix my grammar. But when you're putting in that information and you're providing text that's based on confidential data, it can store that data, and that would be considered a breach. So what can we do to ensure that we are properly using these services? If your agency or organization allows you to use them, some have said you cannot use them at all. And that's understandable because it does create some confidentiality risks. But if you are allowed to use them, some things that you can be aware of. One is don't ever enter confidential data into these types of models. Please don't do it. Like I said, I like to use these services for coding purposes sometimes. What I like to do is I like to create fake data. I can either create a data set that sort of mimics what I want it to, what the data set I really have, 10 observations of data that sort of meet the patterns of what I'm looking for. I don't even like to provide the variable names sometimes because I don't want them to really know exactly what I'm doing because I'm maybe a little bit paranoid, but knowing that they can store my data makes me very careful. So I never, ever enter confidential data into these types of models. I never put in writing that's based on confidential data. And that can help to ensure that they're not keeping your confidential information and using it to improve their models. They also sometimes have a box that says that you can that you can click, and it says that they will not use the information that you input for training purposes. It's always a good idea to click that as well. That doesn't mean you should click that button and then start putting confidential data in. You should still not put confidential data in, but it does give you a little bit of reassurance that maybe they won't be storing your data in the same way. So that's sort of the lowest level of, I'm not building a model, but I'm using AI in my normal workplace. I'm using one of these fancy new generative AI models to help me do my job. So please make sure that you are, if you're using any of these services, that you are protecting the data that you're using with them. The next thing that some of you might be doing is to build an AI model for internal use within your organization. This would be creating a natural language processor, an autocoder, or an image classifier, and a machine learning model, anything that you would be using your internal data to create a model that you would continue to use for internal data. You're not releasing this data, anything to the public. You're going to do some sort of coding or evaluation, and then that might enter into a model that you would release information from, but you're just building the model and using it internally. This is generally fairly safe. It's something that if you're keeping the model in-house, you have to pay attention to the outputs, but the model itself can't really leak much information internally because it's only existing internally. However, as some of the previous panelists have discussed, it can create biased results, and that can inadvertently expose confidential data. So if I'm creating a machine learning model and I want it to classify information for 50 different companies, but I only have information from 5 of those companies, and so I'm going to build it, I'm going to use the training data is going to be built off just those 5 companies, and then I'll use it to predict the other 45, along with potentially those 5 for future use. It can create biased results where if you know which companies are inside that are included in the training data, or if you know something about the patterns of the companies that you're predicting, you might be able to determine some pretty important information from any results that are published from that information. So that's certainly a risk that if we're taking the data that is provided, building a model, and then using that output sort of to predict things that it might not be good at predicting accurately, or it might get biased results, that could certainly leak information about that training data. One of the things that you can do to prevent that type of disclosure risk is you can ensure that your training data reflects general outputs, not just a small portion of those outputs. So you need to have closer to 50 of the companies that you're trying to predict in the training data to ensure that not a couple companies are not too broadly represented in the training data. That can help prevent some of that bias. There's other things that some of the previous panelists have mentioned as well that can help to prevent bias that could leak confidential information. You should always test your outputs to make sure that they're acting as expected. You want to make sure that they look like the universe of of units that you're trying to predict, and not just a couple of the training units. And there's also an option to apply differential privacy to any models that you're using for this purpose. Now, like I said, differential privacy is something that we've been using to protect the data from breaches, from the ability to back out information from tabular data or other released data. But you can also apply differential privacy to machine learning models. And there's off-the-shelf packages to do this now that might not meet all of your needs, but in Python and R, there are differential privacy packages that can be applied to models that are machine learning based or other types of AI models. There are a couple options of ways to do this. One is you can apply differential privacy to the data before it's trained. You can also apply differential privacy to the model itself. And you can apply differential privacy to the outputs. And depending on the type of data and the type of model, the type of outputs that you're creating, it might make sense to do it differently depending on what you're working on. But there are these different options for when you can apply differential privacy. So that can help to ensure that you are protecting that data, those data from once you are ready to publish any outputs that are based on them. Third, we are building AI models, and now we'd like to release them to the public. So one of the neat things about working with good quality federal data is you can build some really neat AI models. And then there have been times where others have said, well, we'd like to use your model too. I had a request at a previous agency where there was a request to release a machine learning model that we were working on to the public because there were other places that had similar types of data, and they wanted to be able to classify their data the same way that we were. And we had such rich training data, so much good quality data in there, whereas they didn't have the ability to create the training data themselves. And so they wanted to be able to use our information. Many of the advanced like neural networks models, a lot of the AI models that we use are considered to be black boxes, and that there's a lot of belief that these are really well protected from being able to determine the underlying microdata that was used to build those models, to train those models. And that's true in a lot of cases. They don't often store the individual information, the individual data, but there are ways in which releasing a model to the public can create a confidentiality breach. One example was in using that model that was requested to be released to the public. We took information from a unit that was kind of unusual. It kind of looked unlike most of the other units. It had some interesting information in what was being classified, and we took that and entered it back into the model to see what the predictive rate would be. And the model was able to get it right and have really high probability that it was right. So it predicted the correct answer, and it said it was 99% confident that that was the correct answer. What that meant is, because that unit was so unusual, it meant with almost certainty, if somebody tried to use that, tried to put that into a model externally, they would know that that unit's previous information was included in the training data. And for us, just knowing that that information was in the training data would be considered a breach. And so you couldn't look at the model itself to find out that that information, that unit's information was there, but just being able to use the model to test for information from them was enough to determine that they were in the training data, and that was not sufficient. Also, if we overfit models, that can inadvertently expose data, where if you are able to put in information for, unusual units or something like that, it can help you can determine that they're previously in the data. So there's a lot of precautions that need to be taken when releasing AI models to the public. One basic thing that we had talked about doing was to limit the number of training inputs to only those that occur with certain frequency. So if one of our important variables only occurred within one unit out of the 1,000 that we're putting into it, then we wouldn't use that information. And what it meant was that when we tested the data and we tested for that particular unit's information, the model wasn't very good at predicting it. But because it was so unusual, we needed to protect the information, and we couldn't use it in the training for that, for a model that could be released publicly. Again, we can use differential privacy. In this case, you would only be able to apply differential privacy at 2 of the 3 steps, which are to the underlying microdata or to the model. If you're releasing it to the public, obviously you can't be applying the differential privacy after the model's run and to the outputs or the tabular data that you're producing from it. But you could apply differential privacy to the model or the underlying microdata before running the model. And there's also the possibility to have an internal procedure that allows outsiders to submit data to you, and then you run the model internally, but you don't release the model itself. So instead of handing off the model and saying, feel free to use it as you see fit, another user would need to submit their data internally and have you run it through the model. Now, there's lots of problems, a lot of challenges with that. You may have to get memorandums of understanding or things like that, where you would have to work together to be able for them to be able to provide the data to you, but it doesn't require you to provide anything back to them. So that's another option that can exist to be able to run someone else's data through your model without having to actually release the model itself. And then the fourth thing I wanted to discuss, and I will admit that this is not my area of expertise, is building AI models collaboratively. And this is something that I think has a lot of potential and is not being done significantly within federal government or contractors. So what this would mean is that I have some really cool data, and if there's another federal agency, for example, that has sort of complementary, really cool data, and we wanted to build a model together that would help us both to predict what's going on in the world. It can be really challenging in a lot of cases to be able to provide one agency's information to the other, to provide the data, and that can take a really long time, and there's lots of barriers in the way to being able to do that. One option is federated learning, and federated learning allows you to create a model in a central location that does not keep the information from either of the individual locations. So I would keep my data, I would keep it on my server or my laptop, wherever I'm storing my data, and there would be a model that would be built on my system. And my colleague at a different agency would have the same situation, where they would have their data, they would own their data, they would stay on their system, and they would have a model that would build there. And then somewhere centrally, there would be a model that would take those updates from me and take those updates from my colleague and build a model together. So I never see my colleague's data, and my colleague never sees my data, but we're building a model together that allows us to both have access to information from the other agency's microdata, even though we never get to see it ourselves. So that's, I think, a really great opportunity to advance how we're using AI at places where data sharing might not be so straightforward. Now, again, that may require some memorandums of understanding and things like that, but I do like that as an option for the future. But like I said, I don't know that this is being used very much throughout federal government right now. So those are the 4 things that I wanted to touch on, just different ways that federal employees or contractors are using these types of models, from just using packages or using systems that are already creative, generative AI models in particular, that are built by someone else and owned by someone else, but are really easy for anyone to use, to ways that we can build AI models together and work together while still protecting the underlying microdata from across federal agencies. So to conclude, AI models can pose significant disclosure risks, but as long as we are careful, as long as we take proper precautions and make sure that we're attuned to what's going on with these models, we can ensure that our data are protected while still getting the usefulness of machine learning or other AI models. That is my contact information, and that's all I have for this presentation.
Excellent. Thank you so much, Ellen. And thank you to all of the panelists. I can't get over just how well all of these talks fit together. And I feel like I wish you could see my notes. I've been writing down so much. You guys have all been so informative, and I feel like I've learned so much, and just I'm so grateful to be part of this today. So I think we have about 9 minutes left. It's been wonderful. I've seen lots of activity in the Q&A, which is great. There's definitely some questions that have been answered, so they're all there if you all want to go check. I think the big one is that this is going to be recorded and it will be on the website. So definitely, I know I will be checking it out again. But there are some questions that I want to get to from the chat. I have many of my own, but I think we'll go through these first because I know how to follow up with you guys. So anyway, I will start with the first one. Kristi, I think this is pretty much directed at you, or at least you can maybe try to start answering, but then definitely opening it up for the panel. So the question is, can you speak a bit of the impact of the sale and exchange of individual information by data brokers to train artificial intelligence? And how could this result in bias against groups or targeting of vulnerable groups? And the example they give is the government has strict PII regulations, but they could theoretically sidestep this regulation by purchasing an AI tool that has been trained on public data, which were purchased from brokers. You want to start?
Yeah, happy to kick it off, but definitely would love to get perspectives of other panelists too, because I think this question really highlights a couple of different things that we can look into. And it also is a good example of what I spoke about when I mentioned how interwoven a lot of the challenges with the AI are, that it's hard to separate, the risk of AI promoting bias or exacerbating bias without also discussing privacy considerations. How do we collect the data? What's the consent involved, et cetera? I think there's two parts to this, I would say. There's probably the technical part of the conversation, and there's the regulation part of the conversation, or the ability of data brokers to operate in that industry aspect of it. From a technical perspective, really, I think good data governance can help promote good PII and clean data and ensuring that we're actually maintaining the right representativeness. So from the simple, again, I'm not a data scientist, but starting as simple as doing the exploration, the necessary data exploration, and making sure that you have a representative population, that the question that you're trying to ask is appropriate and aligned to the data set that you're using. An example I like to use that is if you're trying to create, let's say, a model that has to do with car insurance, making stuff up here, that you're actually using the appropriate state, the appropriate country, the appropriate demographic. You're not looking at data from New Zealand to make a decision on Michigan, right? So looking at that appropriateness of the data that you're using, doing the data exploration. There's also plenty of technology now that does help do some of that exploration automatically, that can help highlight that there is bias, that there is maybe not appropriate representation, or that the model's not performing appropriately. And I think a couple of the panelists actually touched on that, making sure that the model and the AI is performing appropriately and consistently across the different demographics. There's also, there's a lot of technical things we could talk about, but I'll also say part of the challenge and part of the conversation that needs to be had is about what is appropriate to be purchased, what's not appropriate to be purchased, and how do we define and scope what needs to be regulated in terms of data. There's a lot of brilliant people looking at data brokers' work, especially recently. I know this is getting more attention now with the recent executive order on some of the data brokers. So a lot of conversations to be had from regulation. I'd love to see if any other panelists have any thoughts on this as well.
Yeah, I mean, at least from my perspective, data brokers' data is, for most of our applications, is not representative. So a lot of data brokers' data, it really has to do with how you interact with the economy. And anybody who doesn't have large interaction with the economy doesn't have as rich data that's in data brokers. And it really does point to the need for high quality official statistics to be able to adjust commercial data for that representative aspect. So it is really, fit for use about how the data, what you're using that data for, and then leveraging other methods to you mostly around having a good probability sample to be able to adjust that data for its limitations.
Yeah, I would just add, I agree with both presenters here. I will say, like, We, as government contractors, are pretty sensitive to our data brokering purchases. We run everything by corporate counsel. We have like a lot of robust processes in place. That being said, it's certainly, it's still a little bit of the Wild West right now in terms of vendor procurement. There is not necessarily a ton of, you can't, to the first question, can you get around the PII limitations by getting brokering data? In some circumstances, it appears that yes, that is the case. I would say the criminal justice space in particular has seen a lot of, I would say, interesting instances and uses of AI-driven applications that might not have been permitted with data that was collected in a different way. I think this is an area where we're going to see the most movement on regulation. There's a lot of bipartisan support for limits on data brokering. There's a lot of concern around the privacy issues related to data brokering. So I would expect this space to change pretty dramatically in the next few years, especially relative to some of the other issues that come up in AI.
Yeah, I think that's great. And I'm just looking at other questions and also trying to be very cognizant that we only have about 3 more minutes. But I think this governance piece is enormous. And I really appreciate that question for bringing that to our attention. So I feel like some of the other questions are a little bit more specific but I do think, Ben, I thought you raised a really interesting point when you talked about sort of making adjustments kind of post hoc. And so one of the questions was, if you could give an example or a process where actual results provided by the algorithm can or should be altered, and maybe why a researcher or maybe policymaker would want to do that.
Yeah. So a lot of this goes hand in hand, that you need to have your measurement of fairness and whatever definitions you take of that in hand with your mitigation. So if you are experiencing in your original model runs some unbalance or unfairness coming out of your metrics, then it's what do you do about it? The post-processing idea, and this is much easier in a binary setting, but basically you shift some people who are on the margin between being classified as yes or no, and based on that actual characteristic to get the probabilities to balance out. The problem then becomes you are then usually take a hit on your accuracy, right? So you are then causing another problem. Whereas some of the other methods that deal with this on an earlier stage might not be making some of those pieces. It's also somewhat feels very arbitrary, right? I'm going to switch a bunch of predictions at the end, and that seems a little bit less maybe robust than having an adversarial model while you're fitting or reweighting the training data before you're even training your models.
I'll just follow up with a pretty explicit example where we do exactly that. We have a final layer in our model that allows a person to say, don't make these 2 items related. And this is in the auto coding setting. So for those of you who aren't familiar, this is oftentimes on surveys. You have short response text boxes. An example might be a college major. We've seen some interesting examples where some of our large language models suggest some comparisons for things like gender studies or women's studies or religious studies or cannabis studies. And the autocoder makes suggestions that might be offensive to a manual coder. And so we allow for a layer right at the end to say, do not match these 2 things together, because we still have a manual coding review process and we don't want to suggest something that would be offensive to someone who reviews.
That's excellent. That's really helpful. Thank you both for those answers. If it's okay, we might stay just a couple more minutes because I do think there's some really great questions. So I'll just keep going, but we understand if people have hit time. But Ellen, there was a question for you specifically about, I think, something that you mentioned with differential privacy. So they're wondering if you could expand a little bit more, provide examples of adding differential privacy to a model. And I'm assuming they mean an AI type model.
Sure. So one of the way that a lot of models are built is they kind of take some information and then it kind of builds on itself. And the way that differential privacy works in this context is it builds some information and then it cuts it back just a little bit. And then it builds some information and it cuts it back just a little bit. And so it does a couple things. One of it is it prevents overfitting. which is sort of a general use also, but it can help to make it so that it's not getting too much information from those individual data points and individual data sources in order to protect the privacy. But we always think that these models, we want it to be the best that it can possibly be, but in order to protect the data, if you cut it back just a little bit through those different layers of the building process, it can help to ensure their protection.
It's great. Thank you. That was really helpful. So Emily, I think one of the things that I just found fascinating with your talk was really sort of that ARB model. And so I am wondering, and again, I know you pointed that there was the paper, it's in kind of preprint, but just maybe we can talk a little bit just about how federal agencies could work collaboratively with academic and industry experts to kind of foster some of that responsible development and the use of AI and figure out ways that an ARB could potentially be set up.
Yeah, totally. That's a great question. I think that, this is a big part of the kind of fundamental shift in regulatory culture in this space. Like for those of us who work with IRBs, we're familiar that IRBs emerged from the Tuskegee experiments not that long ago, and the harm that was caused by like government human subjects research. And I think that we will likely see a similar shift, hopefully not happen because of nearly as negative of an incident. But I would love to see more collaboration in these areas. And I think there's definitely still logistics to figure out, is it, would these boards be housed at individual academic institutions and partner institutions? Would they be housed within the government agencies themselves? Some of this aligns closely with like vendor procurement processes. And so we've seen more standardization and what are procurement officers asking for from their vendors. And similar to the data sheets for data sets that Ben mentioned, we're seeing more of like, can you provide some very specific technical documentation about how your algorithm works. And I think that an ARB could both do that in-house and be a contact out of house for some of those regulatory requirements. And so I'm really excited for us at RTI. Another piece of the exploration was noting that we already had an internal institutional committee, this data governance committee, which was really well positioned to serve in this role. I think we'll see if it's becoming too out of scope and if we need to spin out another committee. But that was something that also came up in my research, was it's much easier to try to adapt this into some other institutional review process than start something new. And people are less averse to it. I think a lot of people don't want more institutional burden, but in a lot of these circumstances, it's really important to slow down and ask some of these questions. And so I think that encouragement in RFPs and other like funding for this type of work would also help it kind of be adopted.
And that's a great point. And I don't know in terms of the other panelists, if that is anything that you all have thought about or is in part of any of the work that you're doing.
I mean, I
And
think
if not,
it's an
that's okay.
interesting outgrowth of data governance boards, which is something I've been both involved in at NASA and at NORC. But I actually will bring it back for more thought.
Awesome. Thank you. All right. Well, we're kind of winding down here. There is one comment in here, and I feel like I have to read it since I feel like it's related to different work that I'm doing. So which hat I'm wearing right now. But there's somebody pointed out that Ellen mentioned the federated learning as part of her talk. And, I think that there is right now, we're working at NCSES within NSF, we're working on creating National Secure Data Service demonstration projects. And I think the question is if this could potentially be a project or something that should be explored more, that could potentially be part of a shared service environment if there is a future National Secure Data Service that is developed. And again, I guess I'm not necessarily posing it as a question. I just thought it was a really interesting point to bring up. So, Ellen, I don't know if you want to touch on that since.
So I don't know of any projects that are doing this, but I would love to see that they exist. I was hoping that you would have the answer. I think you know more about this than about the National Secure Data Service than I do. But that would be really excellent if that could be part of those demonstration projects.
There was some work that the Chief Data Officer Council did do during COVID of developing dashboards and other monitoring techniques around COVID across agencies. but that was in a crisis situation where we were, able to take more liberties. But it is something that can be done, and I hope would be done more across federal agencies.
So yes, I'm noting that, as for future discussion, but really appreciated the comment and the thought behind sort of thinking of this on this more global integrated scale. So I guess, we're a little bit over time, but I just want to thank the panelists again. I just really thought this was a terrific webinar. Want to thank our sponsors again. It was RTI, NORC, and wait, hold on. I know there was a third one too, so I'll mention that one as well. Oh, and ASA. Yes, how could I forget? So anyway, just thank you all, and for being here for this webinar. So just thank you guys, and everybody have a great afternoon.
Thank you.
Thank you all.